Better than we expected when we ordered, but we did expect a lot, so yeah, right up to expectations.
Although the colours and layout will change for Jeff Dixon's planes, this mock-up represents one hard reality. Billions of pounds already spent on an Airbus that has yet to leave the ground.
Now, I wouldn't go as far as to say they bet the shop on it, but they've certainly bet a lot on it. But then, by the same token, we're not betting the shop on buying it, but we're making a huge commitment to an aircraft that hasn't flown. Now, we know and very confident that it will fly, and it will fly very, very well. But still, we're all making very, very big commitments and taking quite a few chances in a development like this.
There are now just 10 months till the plane is scheduled to fly. It's now mid-June, and as the pressure builds to create the biggest passenger plane ever, there's zero time to waste. This is the horizontal tailplane. With a span of 105 feet, it's as big as the wings of a small airliner. Made of carbon fiber in south and central Spain, it's easily the biggest tailplane ever made. The tail fin is another carbon fiber monster. 46 feet high, this component is made near Hamburg in Germany. When installed, it will stand as high as an 8-story building. Airports will have to buy new cranes to service it. Carefully, it's craned into place and attached with 24 titanium bolts. Charles Champion, head of the program, comes to check on progress. Gilles Cormier, the guy who runs this station, has bad news for the boss.
We've got a problem with this, the tail cone. It's 6 millimeters out of tolerance, side to side. It's not good. Not good.
The last piece of fuselage, the Spanish-built tail cone, is out of line.
6 millimeters overall?
No, from side to side.
Okay, I see. Yeah.
This is a more serious problem and will take 3 days to sort out. Time they really don't have.
I think it's one of those phases when where the success of the project is at reach, but you have many elements to tackle in parallel in order to make it happen. So you're under control, but you've got to work fast on several parallel subjects in order to be able to deliver the project at the end.
The next stage is to install the landing gear. These massive parts have to be unbelievably strong. Not only is the A380 the biggest passenger plane ever built, unfortunately, landing gear in general takes a terrific pounding in the real world. Most landing gear engineers have this low-resolution video clip on their computers, a reminder of the extreme conditions that can occur. Heading for the now disused Kai Tak Airport in Hong Kong is a Boeing 747. Approaching in a crosswind, the left-hand gear takes the full weight of this huge plane as it hits the tarmac. That such a difficult landing can be successful, as this one was, is an amazing feat of engineering. That gear was made by the Goodrich Corporation, who are also supplying the main landing gear for the A380. Here, near Toronto in Canada, production is well underway, and testing is just about to begin.
When we have a new landing gear program, we have a lot of tests that we need to do. Strength, performance, dynamics, durability. This one is a performance test. This is one of the first tests we do. It's one of the more important tests. It's called a drop test. What it is a simulation of landing. So when an aircraft lands, an A380 lands, 560 tons of aircraft moving slowly towards the ground, as well as 200 miles an hour down the runway. when the aircraft hits the ground, something has got to absorb that energy. So if you jump off a chair and you land, your knees have to bend and give a little bit. Even just with the weight of a person, you're going to damage yourself if nothing gives. So that giving of your knees, your legs are absorbing energy. That's what the landing gear has to do, but it has to do it for, instead of 180 pounds, it's got to do it for 560 tons.
Suspended inside this huge tower, the landing gear is raised in preparation for the drop. The rig is static, so to simulate the approaching ground speed, smaller wheels driven by powerful electric motors spin the big 55-inch tires in the reverse direction. When a switch is flicked in the control room, a hook at the top of the tower will release, allowing the gear to fall. It must absorb the same energy as a 100-mile-an-hour car crash without being damaged. It's a critical phase in the whole program.
This could be a make or break test. If the performance of the landing gear isn't what we predicted it to be, it could impact the schedule for the first flight. So it's essential that the gear performs how we predicted it. And from these tests we'll be able to tell whether it does.
Soon they'll find out if their latest and largest landing gear will make the grade. Although it's huge, this 6.5-ton component is just part of the A380's undercarriage. In total, it will have 2 6-wheel units, plus 2 4-wheel units under the wings, and a 2-wheeled set under the nose. So what you're about to see is only a fraction of the energy involved when the vast machine touches down.
Okay, I'm going to drop now. Oh, too hot.
Just the delay, you can see it moving here.
Oh.
All right.
The test goes well. Early data shows that although there was an unwanted shudder as the wheels came to a halt, the landing gear shrugged off the huge impact with ease. Back at the factory, there's more good news. With the tail cone and dozens of other problems fixed, the first flying A380 is about to leave the main assembly station. For Gilles Cormier, it's a good moment.
Maybe we forget a little the trouble we encountered during the past weeks, and now we are looking at the aircraft itself, the achievement, more than the difficulties we had.
Now's the chance to see at last the biggest airliner ever built. With the shell of the world's largest airliner complete, things are about to get really complicated. It's July 2004, and the plane is scheduled to spend the next few months in this massive hall, where thousands of parts will be fitted, including over 500 miles of wiring. The man in charge of this tricky phase is fully aware there's an awful lot of work to do by the end of October.
It's a very difficult challenge, because it's a prototype, so it's very difficult to meet our deadline.
Coming up is August, the traditional holiday month in France, when most of the country shuts down. For Airbus engineers, there will be no holiday.